Thank you, Andrew, and welcome everyone to today's webinar. It's called Innovation in Energy Management, and this is the third webinar in our series for this year about Partner of the Year award winners. So we just sent out an e-blast this morning. Hopefully you received it if you're on our mailing list. That went out about 9 a.m. Eastern Time, announcing this webinar and the others that we're having through December. So please be sure to register for those as well if you're curious to learn about tips from our partners. So these partners that we're featuring have demonstrated leadership, innovation, and excellence in improving the energy performance of buildings and plants, and now they'll be sharing their expertise and lessons learned. So before I move forward with introducing the speakers, we'll go over the poll results. So Andrew, if you can close the poll, we'll just review quickly what everyone said as far as your background and where you are located and such. Okay, so just a minute there. And Andrew, let me know when the results are showing. Okay, so everyone should be able to see the results on your screen. So we just listed a selection of property types that we see most often benchmarking in Portfolio Manager. So it does look like we have a majority of people from the office sector, but also a lot from multifamily, K-12, also several from other, and that's completely fine. Don't worry if you had to write in your property types. I'm sure you'll still learn and pick up on some advice from our presenters today. There's just so many property types to list. And then the next question, we are curious where you're located and where your properties are. So it looks like we have people from all across the U.S. and also a handful of folks from Canada and also some other countries. So that's great. We're also curious to hear from those of you who are from other countries and wherever you are, if you have tips that you want to share with us that we don't cover today or other topics that you want to hear on future webinars, definitely go ahead and let us know via the chat box because we're curious to hear what's going on in various regions. And then the last question, we wanted to know, have you benchmarked property in Portfolio Manager? And most people have. That's great if you haven't, and if you're looking to do so, you can let us know if you need help, but at the end of our presentation, we'll be sharing our help page and our link for that, so we'll be able to provide resources if you need help. So thanks everyone for responding to that poll. That was very insightful. So I'll go ahead and introduce our first presenter today. So we'll be hearing from two people. First, Al Scaramelli from Beacon Capital Partners, and then Greg Fisher from Tishman Speyer. So first, I'll cover Al's bio to give you a background of his expertise. So Al's based in Boston, and he oversees Beacon's energy and sustainability initiatives, their capital projects and building operations, and certain tenant marketing and leasing initiatives. Through his efforts, Beacon has been awarded the EPA's Partner of the Year in Energy Management for the past 8 years, including 6 years at Sustained Excellence, and they have LEED certified over 48 million square feet of commercial office buildings. As a member of the Boston Green Ribbon Commission, City of Boston Energy Benchmarking Task Force, and the Real Estate Roundtable, Al brings a wide range of experience for better building performance through innovative capital projects and operational improvements. He has a BS in Civil Engineering from Worcester Polytechnic Institute, and an MS and PhD in Environmental Engineering from the University of Massachusetts. He's also a registered professional engineer. So with that, I'd like to turn it over to Al.
Okay, thanks, Stacy. Hello, everyone. I'm Al Scaramelli. I'm Managing Director at Beacon Capital Partners. And I first want to thank you for taking extra time to be on this teleconference. Well, now I'm trying to figure out how to do this. Wait a second. There you go. Okay. Beacon Capital has been a commercial real estate developer and owner for over 70 years. As Stacy said, we've been Energy Star Partner of the Year for commercial office buildings for the past 8 years in a row. We've owned over 160 large office properties in 10 major U.S. markets in the past 20 years with a value of over $40 billion. And at Beacon, I run the sustainability program, the environmental program, and all of the building operations. And before I joined Beacon Capital Partners about 11 years ago, I ran another company for Beacon that did energy and water conservation in hospitals around the United States. And prior to that, I was a developer, not of real estate, but a developer of large, privately owned and operated energy and power plants. So I've got 3 brief energy saving sustainability projects to show you that we've implemented. The first is technical, but it's simple and effective. And it's something that allows you to generate electricity when you're running elevators. Kind of interesting. The second is really simple, but amazingly effective. And it's getting people to use the revolving doors at the building entrances to save energy. And the third is a really major topic today. It's in the news almost every day. And it's a program that we use with our office tenants, and it's not specific to office buildings either. It shows people what their carbon footprint is based on their current lifestyle. And I'll be done in no more than 15 minutes. The first thing I mentioned was the concept of generating electricity from elevators. It might sound a little bit odd, but it's technical, I said, but it's pretty straightforward. It's called using a regenerative drive. And elevators are significant electricity users in high-rise buildings. I mean, whether it's an office, a hotel, a hospital, some college buildings. And it's pretty simple. The basic elevator design is a simple balancing system where you have a car or a cab and a counterweight on the other side connected with a pulley system. So as you know from your own experience, you come into work in the morning, the cars are filled up in the lobby, and electricity is needed to lift the car up to whatever floor you want to go to. And then when the car is called down the lobby and it's kind of empty, or it is empty, the counterweight's too heavy and you need electricity to run the motor to drive the elevator down and bring it down to the lobby. So that's the bad news. That's using a lot of electricity. But the good news is electricity can be generated when the opposite occurs. So when a car comes down full, it's heavy, or it goes up light, typically at the end of the day, that's an opportunity to generate electricity. At a property in Chicago, it's not just specific to Chicago, but whenever we buy a property, we bring in a technical team, I'm on it, and we look at the types of stuff that needs to be upgraded, replaced, modernized, and also look at energy efficiency opportunities. In this particular case, there was 12 passenger elevators, and we installed in each elevator something called the regenerative drive, pretty simple, to make electricity when the elevators were coming down full or going up empty. So here's a graph of the electricity usage by these elevators before and after the regenerative drives were put in. All those little blips are, each hump is 1 day of real-time electric use. So before the drives were put in, you can see we had about 3 weeks worth of data of real-time electric use. And then after the regenerative drives were installed and operational, we've got about 4 weeks of data. And as you can see here is a solid reduction of about 90 kilowatts of demand on every day, solid reduction in 90 kW. So what does it look like? It's a pretty simple little thing. That little box there down in the bottom right-hand corner just gets put in the elevator control panel. And it helps, or it doesn't help, but it controls the electricity that gets generated and puts it back into the elevator system. You can put it back to wherever you want it. We put it back into the elevator electricity loop, but you can put it anywhere you want in your building, whatever is convenient. There's many manufacturers of this, whether it's Otis, Schindler, Magnatech, Mitsubishi, pretty straightforward. And from an outcome standpoint, it was pretty effective. In this particular case I showed you was 90 kilowatts demand reduction. Overall, we got a 20% electricity savings for the elevator operation. The regenerative drive controller and software is very energy efficient, like 98% efficient. We've saved a little over $30,000 a year on electricity, elevator electricity, and that's in Chicago, so that's not a particularly pricey market compared to, you know, Boston, New York, San Fran type of thing. And it's pretty inexpensive. The total cost to do 12 cars was only $60,000 for material and labor, and that gave a 2-year payback. Then that was without the utility rebate. So it's very, very cost effective. However, one important caveat. The time to do this, to achieve these types of savings and payback, is when you're doing a major modification, controls upgrade to your elevators. That doesn't happen very often, maybe once every 15 to 20 years. But for Beacon and our business model, it happens almost all the time at every property that we buy that work needs to be done on the elevators. So you've already got all the technicians, all the electricians, everyone's already on site. Elevators are taken out of service. They're all being worked on. So it's very simple to spend a couple $1,000s on this box, and very simple to spend a few hours of electrician time installing it and wiring it up. You know, if you weren't doing all of this work and you just wanted to do it, you know, on your elevators to want to do it, you're probably going to spend the same cost for the material, the little box, but you're probably going to spend 5 to 10 times as much labor cost, and you wouldn't have a particularly attractive payback. Also to note that it applies to direct current DC motors and elevators, so you would want to do this and it'd be applicable at systems that were, 15, 20 years old, which in our case, again, the type of properties we buy, almost everywhere it's applicable. Nowadays, AC motors are being used much more commonly, and you wouldn't be doing this type of technology. But there's a huge percentage of the market out there that can use this. Pretty simple, pretty easy to do. All the elevator service companies know how to do this, very straightforward. Okay, the next one is our revolving door program. This is pretty fascinating. Many commercial office properties and other properties have revolving doors when you enter the building. And they almost always have these side doors that swing out. You might have a handicap button that presses that opens it up automatically, or another one that you push it open manually. So property in downtown Boston, its main entrance is a revolving door with 2 side doors. It's got a really nice lobby, lots of natural light, a very attractive open air coffee cafe, and a lot of lounge area seating. It's perfect, right? Sounds good. Only problem was that the lobby temperatures were 15 degrees too cold in the winter and too hot in the summer. No one wanted to sit in the lobby and read something or talk, have a cup of coffee from the cafe. No good. So what was the problem? We looked at the HVAC the first thing. Nope, that really checked out good. The problem was that many people were using the side swing doors to get in and out of the building and not the revolver. And when they open that door, manually it's open maybe 10 seconds, or if you hit the button, it's going to stay open 25 seconds. Outside air was getting sucked into the lobby. We only had a slight negative pressure, so it wasn't an HVAC balancing issue, but still a little bit negative, and that was bringing the air in. So what did we do? Here you go. The typical sign that you would see, please use the revolving door. I didn't even notice this in our building, that it was there, because no one looked at it, no one even cared about it, and it didn't change anyone's behavior whatsoever. Here's what we did to solve the problem. We came up with a very colorful, eye-catching decal system. We put it on the side doors, both going in and coming out, and we also put it on each of the 4 glass panels on the revolver. The side doors were encouraging people to use the revolver, and the glass panels on the revolving door were more like a pat on the back, thank you for using it. We got input, this is pretty interesting, we got input from a psychologist on the effect of different colors on the brain. because you know we wanted people to look at this in a fraction of a second, make a decision of what they should do. So we needed the color to hit you quickly, the symbols to hit your brain quickly, and get you to do something physically different. We told the tenants about it in advance. We sent them flyers, you know, the day before we put these decals up. And after 1 month, the results were amazing. The revolver use increased from 70% to 94%. We had an additional over 700 revolver uses a day. And the most important thing, which was really the comfort issue, the lot became very comfortable. People started sitting down there, doing some work, chatting with other people, grabbing a cup of coffee from the cafe. That turned out to be very, very positive for the tenants. And a secondary benefit, or part of this conference, is we save $50,000 a year in energy for heating and cooling, with a very, very accurate calculation on that, far more than the estimate. So I was really pleased with all this, and I was almost kind of stunned by the results. How could this possibly be? And I had a college student do the original survey over a couple month period, you know, before and after. And it's not that I didn't believe the data, but I said, you know, I've got to check this out myself. So I went over 4 months later, and this is after those decals on the door came down, 2 months after. We didn't keep them up permanently. We took them down after 2 months, which is also part of the experiment. And I sat there from 8 to 9 in the morning, and 112 people came through the front doors. So catch this, out of the 112, 108 used the revolver. One came in with a suitcase and used the side door. A family with a small child came in and used the side door, and only 2 tenants used the side door, one coming in and one coming out. That was a 97% use of the revolver 2 months after the decals were removed. And I would say this is behavior mod at its finest. It's really something. And then we implemented this at other properties in the United States, and we got really good results. And it's super simple to do and very, very, very inexpensive, you know, to make these decals up. It's like nothing. Okay, the third and last one, we call it calculate your carbon footprint. This is something we did a couple years ago that was interesting and fun for our office building tenants at all of our U.S. properties. And it was an event where the tenants calculated their individual carbon footprint. Today, I think you'd all agree that global warming and climate change are in the news nearly every single day. So I wanted to show you what we did, how easy it was to do, and how popular it was. We put posters in the lobby the day before the event. We sent out tenant invites telling them about it to come on down. I think you probably have heard of Captivate. Those are the people that have those elevator messaging boxes inside the elevators. We got them to agree to allow us to advertise on their Captivate screens a couple days before the event. And there was no charge, they said, because they thought this was a very cool green thing to do, so they liked it. We had tables set up in the lobby with laptop computers, and these computers were all already connected up to the internet to a software program to calculate your carbon footprint. It was pretty inexpensive. It cost us a little under $2,000 to rent the computers and tables, and also to have a technician sit there in case anything went wrong with the computer system. We always serve food and drinks. That was probably the biggest draw. We always serve food and drinks, whether it was breakfast, lunch, or dinner. And it was a big hit. Typically, it lasted about 2 hours. Sometimes it had to go longer depending on the numbers. And we always had a staff person present to assist with any kind of, just kind of not technical, not computer-related questions, but related to using the software and how best to answer it. So how did it actually work? typically we might get 6 computers, maybe it was 8. We normally didn't have over 200 participants, but we always had at least 100 people come down. There are a number of different, not a number, but there's several different footprint calculators that are available. We use Global Footprint Networks calculator. There's the link to it. They still offer that today, even though we used it a couple years ago. And they had 2 versions. There was a light version. It only took 5 minutes to do the questionnaire, about a dozen questions. I'd say 85, 90% of the people did the light version. And then there was a full version with a lot more questions, a lot more detail that took about 15 minutes. And the software calculated your global footprint by asking questions about your lifestyle. Do you live in a city or a suburb? Do you live in a house or apartment? What type of transportation you do? You know, do you drive to work? Do you take mass transit? Do you walk? Do you bike? How much meat do you eat? You know, the big correlation, the more meat you eat, the higher your footprint. Recycling, traveling, those types of questions. And at the end, it calculates how many planet Earths are needed to support your personal lifestyle. So for me, I drive to work, live in the suburbs, eat meat, go on vacations, travel a lot. I was 3 planet Earths, not good. But the best person in all of our properties was a person who lived in the city, walked to work, did not own a car, was a vegan, a serious recycler, and never traveled out of the city. It was really quite popular. In one building in Washington, D.C., there was a very large law firm with a very major energy and environmental practice, and I would say that 80% of their employees came down to calculate their footprint. And at this particular property, it was pretty close, a couple blocks away from EPA's office, Energy Star office. So I went over and a couple of the Energy Star folks walked over with me, and they got to see the event in action, which was pretty interesting. One of the reasons I wanted to show you this is that it's not really office building specific. I think it could be easily done at a large retail store near the entrance, in a hospital cafeteria, a campus center, in a public school, maybe a hotel lobby, again, not just for offices. So that ends my presentation on my 3 topics. So thank you very much. And I think Stacey is going to introduce Greg Fisher, our next speaker.
Great. Thank you so much, Al. It was very interesting to hear about your projects. And I think what you've shared is a good reminder that a successful energy management program consists of a variety of approaches. And you don't always have to spend a lot of money to get good results. Sometimes you just need to start with changing the thinking of your building occupants. So we've already gotten several questions for Al, so we'll address those at the end of the presentation, but keep those coming in. And next, I'd like to introduce Greg Fisher from Tishman Speyer. He's the Director of Energy Systems under the Design and Construction, Sustainability, and Utilities Division of Tishman Speyer, and he manages both supply contracts and demand-side energy usage for more than 55 million square feet of Class A commercial properties, and that includes buildings like the Rockefeller Center in New York, the MetLife Building in New York, the Chicago Mercantile Exchange, and the Franklin in Chicago. Greg's central focus is to improve existing building operational ease, energy strategies, and technology systems to ensure the portfolio remains high-performing and competitive in a difficult real estate environment. And he's a New York State professional engineer, and he graduated from Boston University with a bachelor's in electrical engineering and also from Stony Brook University with a master's in global engineering management. So now I'd like to turn it over to Greg.
Thank you for the introduction, Stacey, and good morning to everybody on the West Coast, and good afternoon to everybody on the East. Just want to start off a little bit with what Tishman Speyer is. So we are a commercial real estate company established in 1978. We have assets in 30 markets, 7 countries, 4 continents, and like Stacey said, some of our notable ones being Rockefeller Center 200 Park Avenue, and CME. 2,000 plus tenants worldwide, many divisions within Tishman Speyer, mine being the Sustainability and Utilities Division, but Design and Construction, Investment Management, Property Management, Leasing, Acquisition and Development, and we have over 1,200 real estate professionals in the various divisions. So I'm sure everybody has seen a version of this cross-section of a building which points out a variety of light and heavy technology systems. Tishman Speyer's focus is to utilize these sensor and algorithmic systems to act as one portfolio globally, where factors like local utility tariff structures, the way we procure energy, the available resources, and the government jurisdictions all affect how the buildings proactively and reactively shift in strategy over the course of day, weeks, seasons, and yearly. Monitoring and managing this activity on a global scale for 100 buildings is an enormous task, but our people, our partners, and our investors are excited for the outcomes. So putting the global vision aside for a second, I want to zoom in on a particular technology that we've implemented at a variety of our facilities that has created some great success in reducing our energy usage, peak demand amplitudes, and carbon footprint while cooling our facilities during the shoulder and summertime seasons. Utilizing ice has been around for quite some time. If you go as far back as to blowing a fan over a block of ice and creating cooler air past it, I feel like we've come a little bit and become a little bit more sophisticated and more efficient with the utilization of ice over time, but it is a very powerful storage of energy. It would be very messy hauling up large blocks of ice up to 70 stories of 30 rock, so I'm glad we made that progress. HVAC for commercial real estate is a large portion and kind of grows even as lighting shrinks with LED technology. It is still a large portion of our energy bill. Exchanging from air to water to refrigerant to water again and then back to air has tremendous inefficiencies, but it makes it very convenient when you want to centralize your air conditioning systems within commercial buildings and increase your rentable square footage. So title doesn't lie here. This is a conventional daily electric profile of some of the larger electrical loads within a commercial facility. Air conditioning makes up a good chunk of the profile with the need to move air in the form of fans, move water in the form of pumping, and remove heat from the air and the water in the form of chillers and cooling towers. You can observe very flat profiles for things like your base load, that's 24/7, lighting, some of it's 24/7 but has less variation, your fans, pumps, and cooling being much more variable in the use of electrical loads while cooling the facilities. So as it gets warmer outside, sun bearing down on the buildings during the course of a shoulder or summertime season, it is important to keep our tenants happy and the building cool, so our systems increase their impact in cooling the building. Now, increasing that impact can be done in a couple of different ways. One strategy I just want to level set with everybody is the time of use strategy and what we are held to from a local utility perspective here in New York. Now that we understand how commercial buildings behave at a very high level, it's important to understand how a place like New York gets charged for large commercial electrical usage. X-axis shows your hours of the day, not starting at midnight, but at 8 a.m., and your Y-axis shows the amount of ice, if you were to have ice in your facility, for a thermal storage plant. Our operations team use our control systems to take advantage of the lower off-peak rates of electricity to build ice over the course of several hours. That same operations team, after they are done building ice, start melting the ice when what we call a burn, starting around 8 to 9 o'clock in the morning, 8 a.m. is a significant time, especially here in New York, because it is the start of when large commercial buildings get charged a lot of money to use their use electricity. The burning of the ice happens over the course of 9 to 10 hours during the super peak demand window, which avoids the use of heavy electrical users of air conditioning like chillers. This concept is taking advantage of the time of use tariff structure. I kind of skipped ahead to a little bit in the last slide of why thermal storage is successful in regions like New York that have high deltas between their off-peak and on-peak electrical rates. But getting back to some of the definitions of what thermal storage is, it is designed mostly to reduce costs by shifting all of the energy you would use in the middle of the day with chillers to at night in the form of ice storage. Naturally, that has some ancillary benefits to it that we'll get to in a little bit, but that is the main driver behind payback periods, ROIs, and showing the usefulness behind thermal storage. Same concept. This is the same concept as what's your ice maker at home, where your freezer uses electrical energy to form ice cubes in an exothermic reaction. That release of energy from converting water to ice and having that freezer take that heat away is the same concept for ice commercially. The freezer stores the ice cubes and keeps them frozen until we use them to drink, where an endothermic reaction takes place and the heat of the building gets transferred into the ice. So this shows another daily profile of a commercial building, but now we are looking at the cooling load, which is a following effect of electrical load, but follows outside air conditions and occupancy changes for commercial structures. All of the energy that we would use with chillers midday, which is shown in red, is shifted to at night where we go to build ice, which is shown in green. The blue chiller portion shows small chiller usage during the hottest days outside in a partial thermal storage system, or else the amount of ice you would need in a full thermal storage system would be tremendous. And with the space at a premium in cities like Boston and New York and Chicago, you also run into laws of diminishing returns as you increase the amount of ice you have. So it's important to have a balance between your chiller load and your ice load at the same time. Knowing all of this potential in using thermal storage and the successes we've had at other buildings, we turn to one of our most well-known facilities in New York, if not the globe, which is Rockefeller Center. So 45 Rock, which is seen in this picture, is one of the 12 mixed-use commercial buildings in Rockefeller Center, but the second largest in square footage at 1.3 million square feet in the northeast corner of the plaza. It is home to our global headquarters, Tishman Speyer's global headquarters, amongst other notable financial, retail, and jewelry companies. In the depths of the beautiful Indiana limestone at the surface of 45 Rock, though, we see a tired and inefficient central plant that was on its last leg in being able to effectively cool the north block of Rockefeller Center. What you see in the picture is RM2, what we called RM2, which was a 1,200-ton, 35-year-old chiller that was removed from the facility in buckets. This is another picture of some of the old condenser water pumps that used to circulate water in between the plant, the central plant, which is located in the sub-basement, all the way up to the roof of 45 Rock, which is 40 stories. And there are valves that look like we were operating a submarine instead of a commercial property. This is there are a lot of words and stats on this slide, and is fully this is intent to read rather than me talk about. I don't want to stay too long on this, but these kinds of figures show we were terribly inefficient before with our central plant usage when it came to our cooling systems. We designed a plant that fit in almost the same footprint as the last one, but had gigantic amount of firepower in the form of chillers, pumping, and thermal storage. We had the luxury of voltage changes to the machines as well, and as well as increasing delta T of the machines themselves while designing them, and reducing the amount of pumping to form primary pumping strategies. We'll get to some of the successes and what this means in some of the pictures that I'll go through in a second. This was a conceptual layout of the new plant, where it shows 3 chillers in a horseshoe configuration on the left, pumps to the north, and a whole bunch of ice tanks where a lot of the old chillers and pumps used to be located. Here you'll see another 3D design layout of the tanks with all of the glycol or antifreeze that we use to freeze the tanks, with all of the piping connections. It was very interesting and very helpful over the course of the project that we did 3D imaging of our old plants and our new plants, where they go around and scan 3D images of the walls and piping and conduits and everything that surrounds it. If anybody has walked the plant with me before, which I know a lot of people on the phone have, they know I still take down a lot of a couple of the million camera targets that were used for the scan. They still continue to be everywhere, and I find at least one per day, but still working on it. So the ice tanks. We have 61 of them total. Each tank has 3 miles worth of polyethylene or plastic tubing in each tank. I like to think of this as a big thermos with a heat exchanger in it, which keeps all the heat of the surrounding environment out, and all of the ice that we make overnight in until we're ready to use it. We had some of the best people in the contracting world on this job doing demolition, electrical, mechanical, plumbing, and rigging work. We consumed a large amount of woman and man hours in a very condensed amount of time. It wasn't possible without the orchestration of the trades while keeping the building active. But you see a couple of pictures of us chopping up the old machines and taking them out of the building to make way for the new equipment and the new thermal storage system. This was a lot of old electrical equipment used to power the old chillers and the pumps. There was a lot of low voltage, 208 volts being fed to the old plant. We freed a lot of that up and replaced it with 480 volt and 4160 volt equipment. Not everybody has those available resources in their building, but we were very lucky in that respect. This is just a pile of old piping. Surprisingly, all of the piping was very clean for being there for over 50 plus years, but it needed to go with the new space utilization of the central plant. Here's a little bit of prep work that we did while we cleared out this space. You'll see a lot of those camera targets that I was talking about on the walls. But that's all the 3D imaging that we did beforehand. We had to rig the chillers in, rig the tanks in. So rigging company right out front of Radio City Music Hall on 50th and 6th Avenue. We got 61 tanks into the sub-basement of 45 Rock. Each tank is anywhere between 150 and 200 ton-hours of storage. The total amount of energy that we now store on a daily basis is to the tune of 11,000 ton-hours. This was a little bit more rigging, so the tanks needed to be lifted by forklift in the middle of the street and then brought straight down the loading dock ramp. And then after that, we needed to flip them on their side in the loading dock itself because the tanks aren't collapsible or they can't be broken down any further than they already are. They needed to go down horizontally, skated them in through the meandering hallway to where their final resting location was, and then flip back up on their side. Tanks can be, like I said, tanks can't be broken down, so this was a necessary process. First one was hard, but the following 60 kind of fell into place. Final resting location, picture of our prep work paying off for a good placement of the tanks in the most space-efficient honeycomb configuration. This upper mechanical room space was commandeered by the project team in a last-minute design call to increase our ice storage capacity. Needless to say, the operations team was not happy that we commandeered it, but it was to the building's benefit. Quick picture of one of our new pumps just hanging out in the loading dock waiting to be installed. This pushes water through the plant and through our buildings and all the way up to the roof, but our pumping strategy changed from a primary-secondary strategy to a variable primary. Picture of one of our large holes that we made in the mechanical room, but in the rig path, to get our chillers where they permanently reside today. This is a picture of a condenser barrel upside down, getting rigged down a ramp into the lower mechanical room. Our chillers now have a total of 4,000 plus tons of cooling capacity. This is a picture of our chiller fully assembled. Just kidding. In order for us to get the chillers in the final spot, we needed to break them down in a million pieces and reassemble them in place. Final product. That's one of our new workhorse chillers at medium voltage, 4160 volt. We had to pipe conduit 1,600 feet away to take advantage of this power feed, which saves a tremendous amount of peak demand charges on our utility bills. Some of the plate and frame heat exchangers, as you see here, glycol going in one side of them, which is our antifreeze from the tanks, and the other side exchanging that to chill water. In this case, we are looking at the glycol plate and frame heat exchangers, but two of them at 1,200 tons. We have 2,400 tons of cooling capacity out of the tanks at our disposal. So final shot of the engineer shop that I showed the prep work for and that we commandeered, but we now have a total of 20,000 ton hours of ice storage in Rockefeller Center, which is upwards of 2 million pounds of ice that we make every day. It's funny that whenever we bring tenants down here to view the plant, they always they either have one of two different things. One, they think that we're storing nuclear waste in the basements of Rockefeller Center, or that we're making ice for margaritas and mixed drinks later. But everything's used for comfort cooling when we build ice. Snapshot of our control system, which is animated and has a lot of important values while running the facility live. Some energy stats at the top right of some of the things that we did as far as on-peak demand management, our chiller efficiencies, and our pumping efficiencies having great improvements. And some of the ancillary benefits of this become the final plant success statistics in the form of carbon emissions world, where we take advantage of the off-peak greener energy rather than using energy while the peaker plants come online in the middle of the day. That is my final slide. I'm going to hand it back over to Stacy, but thank you everybody for listening. And I'm here to answer questions.
Awesome. Thank you, Greg, for sharing your story. I think that's definitely inspiring to see how the logistics for such a large project has to all work together to pull something like that off. So that was really great. And, of course, that kind of project is not going to be realistic for everyone on the webinar, and we know that, but hopefully Greg's story will maybe inspire you to start thinking about demand-side management in your own building in some other ways if you can't exactly pursue this ice storage. So as far as upcoming webinars, before we get into Q&A, we'll send out the slide deck after the webinar today, and you can register for our upcoming webinars. So we hope to see you in the coming months. And now we've already received several questions through the chat box, so we'll move forward and jump right in with posing questions to both Al and Greg.